All right. We're going to learn some vocabulary words. This is section 1-2. Put practice on it. The date is the 3rd. And put section 2 on your paper. 1.2, 1-2, I don't care. You can just put section 2 too, also. All right. We're going to learn first the words integers, irrational numbers, natural numbers, rational numbers, and whole numbers, and what they are. Couldn't keep up? Had a hard time? All right. 2, just section 2. No, it was 1. Section 1. This 1-2, you kind of see it up here. I didn't put it in the paper, but hey. All right. A little slower today. We're going to learn, integers, irrational numbers, natural numbers, rational numbers, whole numbers, and what they are. All right? The natural numbers and 0. Okay, first, does everybody know what natural numbers are? It's a regular number. It's natural, yes. What's that? Right. Decimal? Whole number? Here's where you get your Chromebooks open. If you don't know, you Google it. It works good, though. Now, we're going to put in natural numbers. I didn't spell natural right. Well, I did, but it didn't take it when I pushed on it. Oh, I'll tell you, this is rough. This isn't a kind of a Q, a natural numbers. Natural numbers. All right. Well, I've always looked these up. I have it on here. Natural numbers. I just looked. I was looking in number lines, seeing if we could come up with a natural number for it. This recording I want to keep up here. And I'm not seeing what I want to see. Natural number. Basically a natural number starting at 0 and it's going on to infinity, but it doesn't have decimals to it. All right? Guys, pay attention. Irrational numbers. What are irrational numbers? Nope. Irrational numbers. Irrational numbers is like pi. Pi continues on forever and never repeats itself. Yes. First one up there? No, the natural numbers in 0. What are natural numbers in 0? Whole numbers. We could write that in there too, I suppose, hey? So what are natural numbers? Natural numbers right here are going to, where are my natural numbers? Right here are going to be 1, 2, 3, on up. All right? Natural numbers, they're opposites and 0. What are they? They're opposite. In other words, they're going to have -2, -1, 0, 1, 2, 3. Keep it on going both directions. Irrational number keeps on going. In other words, 3.141592653, that turns into an irrational number. What would it be on here? We already have whole number on here. Integers. Integers. And what do we have? Whole. All right. The numbers that can be written as quotients in integers. If I wrote 1/2, 3/4, what kind of numbers are those? We already had whole numbers. They're what? Rational numbers. The numbers used for counting. Natural numbers. Getting a little fast? All right. Give you a second to catch up. I want you guys to learn this, understand it. You don't have to write this whole thing out here. Okay. Because if you have this and you pull this up to study off it, you know number 1 is whole. Number 2, integers. However, that's fine. You guys ready? All right. So you're trying to write this stuff down. All right. Part of the reason why I have it on a Chromebook is so you don't have to write it down. The numbers that cannot be written as quotients of integers. It's irrational. Pi. Pi is a great example. All right. Irrational. Pi is a great example. Because pi keeps on going, right? It's 3.141. It keeps on going. It never ends. That's an irrational number. What would be another irrational number? Anything that keeps on going and never repeats. Anything that has a decimal on it that keeps on going and never repeats. Is 0.3333 rational or irrational? It's rational. Because it repeats itself. I can write it as this, 0.3 continuing. Okay? So that is a rational number. But anything that doesn't repeat itself and keeps on going is an irrational number. Okay? Everybody got that one? We're cool to move on? All right. I hate them. I hate them. Yes. I love salmon. All right. All right. Let's take a look at these numbers up here, and let's figure out if these numbers are whole numbers, natural numbers, rational or irrational numbers, or integers. Let's take a look at whole numbers. What are whole numbers again? 1, 2, 3, 4, 5, 6, 7, 8. What are 0? 1, 2, 3, on. This is whole. 0 is not a natural number. All right. Natural numbers, where do they go? Natural numbers. 1, 2, 3, 4. What's a rational number? What's rational? We just did this. Look back at your notes. Yeah, anything with quotients. So we can say that rational is going to be 1/2, 3/4, something in that nature. It could be if it had defined. Remember, what's irrational? It continues. So if we take 1/2, 1/2 is really what? 0.5. 3/4 is really 0.75, right? But if we take pi, 3.1415, blah, 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 blah. All right, that's irrational. And then what are integers? What are integers? Nikki, what are integers? Anything that doesn't have a decimal to it. All right, so we could have integers would be -2 this way, -1, 0, 1, or 2. Keeping on going. Okay, so let's take a look at these. Which numbers up here are whole numbers? 0's in there, right? 27 in there? 27. Is -12 in there? Is square root of 81? Yes. Here's a radical chart right here, right? We take a look at square root of 81, it's 9. So we can say -12. Is that in there? No. Silly me. Square root of 81. Is 0 in there? Yes. Is 5/7 in there? No. -105. Square root of 44. 93. Yes. Okay. How about natural numbers? Natural numbers. Remember, natural numbers start at 1 and go. Is 27 in there? -12. No. Square root of 81 is in there, right? Because that's 9. Is 0 in there? No. Natural numbers starts at 1. 5/7. -105. Square root of 44. 93. Yes. Rational numbers. What are rational numbers? Do they have to be fractions? Is 27 a rational number? Brad, is 27 a rational number? You're wrong. Yes, you are. 27 is a rational number. It's defined. It doesn't go any farther than that. All right? It doesn't have to be in a 1/2 form or 3/4 form. It just doesn't go any farther than that. How about -12? Is that in there? Is it a defined number? It's a defined number. Is square root of 81? Square root of 81. Is 0 in there? Yes. Is 5/7 in there? Is it defined? Can we come up with a definite, and it stops? What's 5 divided by 7? Does it keep going? Use a calculator. Divide 5 by 7. 2 point. It keeps on going, doesn't it? Keeps on going. So is that one an irrational number? Does it repeat itself? Does it repeat itself? I gotta find the calculator that I can put up on the screen. If you take a look at it, it does start to repeat itself. 7142885. Then it repeats itself again. 7142885. And it keeps on doing that repeating. So it is a rational number. It is. It repeats itself. 5 divided by 7 equals, what did I come up with? 0.714285, and then it starts repeating itself again. 714285. And it keeps on going. If it repeats itself, then yes, it is a rational number. How about negative 105? Yep. How about square root of 44? Can you do the square root of 44? Sure you can. Square root of 44. Ooh, baby. It doesn't look like it repeats itself, and it looks like it keeps on going. I would guess that square root of 44 is not a rational number. It's probably irrational. How about 93? Yes. Okay, so we've got that. What would be the irrational numbers up here? Notice we have all the rational numbers. Which one would be irrational? Square root of 44. All right. Integers. What integers do we have up there? What are integers? Whole numbers, right, that go negative and positive with 0. 27 is? Negative 12. Is square root of 81? Is 0? Yeah, right here. Take a look right here. All right. Right here is where we got our integers. It's 5/7. Reese. No. Is on negative 105? Yes. How about square root of 44? No. What about 93? Yes. All right. All right. I'm not going to draw a diagram. Everybody got this? They're cool with this? All right. Realize, too, guys, if you don't get everything here, it's also in a recording that you can go online and grab. I'm not hitting the pause button. Hit the pause button, he says.
Fire up the laptop. Mine's fired out. Hey, don't turn the lights on.
Did we go through 1 and 2?
Yeah.
We did both of them?
Yeah.
We're cool to go then?